Which pair of elements will form a nonpolar covalent bond? Then we have basically A, B, C, or D. So which pair of elements will form the non-covalent bond? HCl, NH, NCl, or OH? And we have a beautiful table that tells us what each element is and what its given electronegativity is. So beautiful. Now just know that if you want to find out different types of covalent bonds, there's two different types. There's the nonpolar, and then there's the polar. If we want to find that out, and they give you electronegativity values, the easiest way to go about this is finding out the electronegativity differences between the atoms in the bond. Electronegativity is basically just to tell us what attractions the atoms have to that shared electrons in that bond. Some of them might want to, grab the electrons and bring it closer to them if they can, right? If they have a greater attraction, the electrons are going to go closer to the atom that has a higher electronegativity. So if they give you the electronegativity, all we have to do is just find out the difference, which means that we just have to subtract the electronegativity values of the two atoms. So let's just write them out. So I see a lot of hydrogens here. Hydrogen on this chart is 2.1. So I'm going to say 2.1. Here's a hydrogen 2.1. And here's a hydrogen 2.1. Let's see what else we got. We got chlorine. Chlorine is 3.0. So 3.0 for this guy, 3.0 for this guy. C.0. Isn't it interesting how my brain works sometimes? Sometimes it makes me wonder. We got a nitrogen here, also 3.0 for both of these guys. And then finally, we got oxygen, which is 3.5. Maybe I'll do that in white. Okay. So let's take the difference. Now, just know that the electronegativity difference when you do it is always going to be a positive value at the end of the day. It's the absolute value. So if you subtract and you get a negative value, just make it positive. The easier way to think about this is to just take the higher number and subtract by the lower number. So for example, in my mind, I would take the 3 and subtract it by the 2.1 and make it positive, basically, right? So this would be 0.9 positive. And let's just do it for the remaining ones. 3.0 minus 2.1, that's also the same number. So, troubleshooting and problem solving, tips and tricks. If you have the same electronegativity difference for both of these, there's no right answer here, right? How could this be the right answer when I have the same electronegativity difference? So automatically these go bye-bye. That's fun. 3 minus 3 is a big fat 0. And then 3.5 minus 2.1, that's a 4, 1.4. Okay, so now we just have to determine between 0 and 1.4. Now, if something is nonpolar, the general idea for this is that the electronegativity difference for nonpolar, you have no pull, right? Polarity or polar means that you don't have, one atom doesn't have a greater attractiveness towards those electrons than the other atom, per se. So that means that basically the electronegativity difference should be really, 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 really low. The lowest number you could possibly get is big fat 0. For your nonpolar bonds, your electronegativity difference should be from 0 all the way to 0.4, or up to 0.4, right? So, in this case, I have a 0 and I have a 1.4. This is the lucky value. If you have no difference, right, nobody wins, nobody loses. You can think of electronegativity differences as winning the game, right? Winning the soccer match or, whatever your favorite sport is. What's your favorite sport to watch on telly? On the telly? Me? It's a toss-up. It's soccer and tennis, but I haven't really been watching tennis anymore. Federer's gone, Nadal just left. Oh, reminds me of for me, the better watching days. So now I'm ramping it up on soccer, Premier League. Let me know. But anyway, if it's a 3-3 game, nobody won, nobody lost. So the electrons are right smack in the middle. No one element is pulling those electrons towards it. And that's a nonpolar bond. No pull. So we know what the answer is. It's NCl. And this is a great example to show you that sometimes you can have different elements, but the electronegativity values are still going to be the same. So it's going to be nonpolar. So sometimes, thinking of it as if you have just two different elements, you're going to be polar. Sometimes that's not true. But anyway, thank you so much. Hopefully this helped. Let me know in the comments. Subscribe to the channel. Like the video if it helped you out. Tell your friends, tell your classmates. Just gets the word out there, and thank you so very much. We also have tons more questions on our website, glazersguide.com. I'll leave a link in the description and also a link at the end of the video if you want to just click on over there. Tons of videos. My brother and I, we created every single video. And we have deep dive videos on these topics where we could just chill, hang out, and learn. And yeah, it's pretty cool. What do you think? Anyway, I'm going to go to bed. It's pretty late. But I will talk to you later. All right? Have a good day. Here comes the outro music.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.